Hello, this is Mr. Ferris. I'd like to walk through problems 5 and 6 on lesson 8.3, constructing confidence intervals for a mean. Number 5 has 20 screen tension readings in millivolts. And so we begin with just a set of data and a story that asks us to construct and interpret a 90% confidence interval. So first of all, we have to check conditions. That's always the first thing we want to check for any statistical test or confidence interval. So first of all, we check to see if the sample is random. It is stated, so we can just write sample is random. That was in the, here it is right here, that was in the stem of the problem. Condition number 2, we want to make sure the sample size is big enough. Well, there's only 20 screens, so that's not large. It's not really small. It's a healthy sample, but it wouldn't be considered a large sample. So we really would do better if we knew that the population that came from was normal, but of course that's impossible as well. So we're kind of in a dilemma of what to do. We're pretty certain that 20 screens at random is still a pretty decent sample, but it would be nice to know that the population is at least close to normal. So although we don't have the population, we do, of course, have the next best thing. We have a good sample. So if you type these numbers into your calculator, you're going to need to do that anyway because we have to get the sample mean and the sample standard deviation. So we're going to have to do that anyway. So you might need to pause the video so you can type these in your calculator because we want to take a look at the shape of the sample. If the shape of the sample is at least relatively symmetric, then we could maybe assume that it could have come from a normal population. So I've already done that in Fathom. Here is what you might do even on your calculator. You can construct a histogram on your TI calculator and you look at the shape, and at least what we can say is there's no reason to believe that the population is not approximately normal, because the sample itself doesn't seem to have any outliers or heavy skewness. So with a decent size sample of 20 and with no evidence that the population is not normal, we kind of say something kind of like what I just said. So we can say that n is not large. That's true. But a histogram of the data shows no outliers or heavy skewness. And if we just draw a quick sketch, let's go back and see what that looked like. A quick sketch of that. Then, let's see, maybe I could even pull that over here so I can kind of see it while I'm doing it. If I can just draw a quick sketch, that would give me a little more credibility. So something like this. And if you just even get a rough sketch of what you saw on your calculator, that will give more credibility to what you just said. You didn't just make that up, but you actually looked at it. So even if you just do a Zoom standard, or I'm sorry, a Zoom statistics, Zoom 9 on your calculator, you should be able to see at least no evidence that the population is not normal. So we will proceed cautiously from that. And then surely, according to the story, surely 20 of these things is less than 10% of all video terminals. Therefore, since the conditions are met, we will proceed with a one sample T interval. That's what we're going to build. So our conditions are met, we're good to go. So if we type these into our calculator, we'll find out that x bar, the sample mean, is 306 0.32 millivolts. And the sample standard deviation is 36.21 millivolts. Our degrees of freedom, we might as well write that down while we're at it. Degrees of freedom would be 20 minus 1, which would be 19. We'll need that later. And so if we do our, if we look up on our t-table to see what our t-star number needs to be, our t-star number for 90% confidence, and for 19 degrees of freedom, if you look that up on your t-table, you should get 1.729. That's what we will use to build our confidence interval. So now we just need to fill in some blanks. Our statistic is x bar, so 306.32 plus or minus our critical value, which we looked up on a t-table, 1.729, times the standard deviation of the sampling distribution for this, which will be S, 36.21 divided by the square root of our sample size. Remember, it's the sample size, not the degrees of freedom. And then if you want to, you can type these. Well, you've already got the data in list 1 by now, hopefully. And so you go down to stat, test, and find your one sample t interval. Type in everything that, well, you don't type in the statistics because we have the data. So you choose data. And you should be able to find that the interval is 292.32 on the low end, 292.32 up until 320.32. So there's our interval, and so now we can interpret it and say I am 90% confident that the true mean tension is between 292.32 and 320.32 millivolts. And that would be the interpretation. Always make sure that the confidence interval is referring to the true mean. Make sure you communicate that clearly. You're not writing a confidence interval about the sample mean, so don't make any sort of statement that would tend to hint that you're talking about the sample mean. That would always get a deduction. But you are confident that the true mean, the actual mean, the population mean for some item is between the boundaries of your interval. So there is one completely worked out. And just a note that would be worth mentioning here at the end. In confidence intervals, some of the things that are always graded, and it generally goes like this. One thing that's typically graded on confidence intervals on an AP test is the conditions and the name of the test. Many times they're lumped together. The conditions and the name of the test. So we accomplished that by making a nice organized list at the very beginning. And then we just followed that with, okay, since we met the conditions, what are we going to do? It's just a good habit to get into that, to say, okay, now we're going to proceed with, and then you write what you're going to proceed with. And remember, some of these names for the tests and intervals are right there on your calculator, so it can help you remember how to say that correctly. So that's usually 1 point. And then another point is typically for the calculations. And the correct answer, of course. Now, calculations, what we really, the basic calculations are right here. It's really a formula with the correct numbers plugged in. Now, we had to look some stuff up. We had to calculate a mean on our calculator. We had to look up a t critical value. And then we had to do a calculation with S divided by the square root of 20. Not to forget that. It's not just divided by, or it's not just 36.21, but you have to divide by the square root of 20. So there were some calculations inherent in the formula, but there's your work. And then, of course, the answer would be the two numbers there. And then the third point typically is the interpretation. And that will get pretty good after a while. Again, the key thing is to make sure you're always referring to the true mean or the population mean. And sometimes also they look for, I'll just put this as a question mark, sometimes they'll want you to state the parameter of interest. And the reason I don't really think that's a big deal is because if you do a decent job like we have been trying to do, the parameter of interest is going to be written down in here in at least one place. Most of the time it's going to be clearly written right here at the end that you were searching for, you were estimating the true mean tension of these video terminals. So the parameter of interest will be clear in your conclusion if you write that well. It wouldn't be a bad idea, I suppose, to get into the habit of saying that at the very beginning, that we are trying to estimate the mean tension on these video terminals. Okay, well that is an example of a confidence interval given the data. Number 6 is still a confidence interval for a sample, using a sample mean, but you'll notice this time they give you the mean reading and they give you the standard deviation of the sample. So they basically are giving you X bar and they're giving you S, and so you don't really need the data. The only thing you would need the data for at this point would be the shape of the population. That would be the only thing you might want to use the data for. But if you look at the sample, notice they gave you a sample of 40, therefore n is considered large, and therefore we don't even need to look at a graph of the data. We can just proceed because a t-procedure will be robust with a large sample size, and so we're going to be good to go. We should be able to check all our conditions and should be able to do the calculations from the given information. So you'll notice that you don't have to have data. You might be given enough information with the mean and standard deviation statistics and with sample size to proceed with a confidence interval. So there's just a couple examples to get you started. Hopefully this will come with doing several different problems. Usually doesn't take too long to kind of get the hang of it. So if you have any questions, make sure you note those, bring them to class, and I'll see you then.